It is now time to learn about polar coordinates and polar graphs. Has anybody here ever actually made polar graphs or worked with polar coordinates? So did you learn it in Mrs. Lofgren's class? Yeah. Well, you did do it in Mrs. Lofgren's. Did she pass out polar graph paper?
Yeah.
Okay, I'm not going to do that. So you're just you're on your own as far as that goes. You're going to just have to estimate these angles. Because I don't know, polar graph paper to me is really ugly. I'd rather just take my chances and get close than to be exact and have this ugly polar graph paper. Okay, here we go.
Like the flower.
Oh, but that was
It looks like a full.
No, I think you like dotted graphs that we could picture.
I don't think so.
Polar coordinates. You know how we like to make our graphs with x comma y? We learned that even with when we played Battleship as kids, only with letters and numbers. We go G8, and it's a hit. You sunk my battleship. You know. Well, we don't do letters and numbers. We do numbers and numbers. This is the x coordinate, and this is the y coordinate. So if there's some point here, we know where that point is because we go over to the right on the x-axis and go up along the y-axis, and there's our point x comma y. This is intro. But now with polar coordinates, we're going to find that point a different way, okay? We're going to do this. We're going to say, okay, I'm going to draw a segment from the origin to that point. There's the segment from the origin to the point. And then I'm going to make that segment into a stick, or I'll cut a stick that's the same size as that segment, and ask myself, if my stick had begun on the positive x-axis, what angle would I have had to rotate this stick so it ends up right there? You see? And so now the only two measurements I'm making are the length of the stick, which I call r, and the angle that I have to rotate the stick relative to the x-axis, which I call theta. You see? So if someone said, hey, Mr. Shana, here's 1, here's 2, here's 3, here's 4. Let's do that, okay? And someone said, hey, Mr. Shana, I want you to graph the point r comma theta equals 2 comma 40, let's make it 45 degrees. No, wait. If they said, hey, how about 2 comma 135 degrees, if that's my r comma theta, I'd say, okay, I'm going to make a stick, and that stick is going to have a length of 2. So there's my stick with a length of 2. And then I'm going to rotate that stick 135 degrees, alrighty? So that stick gets rotated to here, which I'm right there. And this is the point, 2 comma 135 degrees. You guys okay with that?
Yes,
That's
sir.
all you're doing, getting the distance from the origin and the angle that your stick has to be rotated, and now you get to find that point. Now, one thing about polar coordinates, of course, is because we're in calculus land, and because we're going to end up taking integrals, and you know when you take integrals or derivatives, you have to be in radians mode. The derivative of the sine of x is equal to the cosine of x only in radians mode, not in degrees mode. So I'm not going to give you a problem like this. I'm going to give you like 2 comma, what is that? 3 pi over 4. Thank you. 3 pi over 4. Because I'm going to have to give you the angle in radians, not degrees. But I'd like you to go ahead and plot the following. Just see how close you get. Plot the following. How about 1 comma 0? Go ahead and make your axes, bless you.
Thank you.
Make your axes and scale it in some fashion. Okay? And I want you to find the point 1 comma 0, but remember, this is now r comma theta. So my r is 1 and my theta is 0 radians. Please do that now. Here. I'll call this point A.
I'm terrible climbing.
I'll give you 15 seconds. Okay, time's up. I hope you got your stick has a length of 1 and the angle is 0, so you should be right there. That's point A. How many people got that that's point A right there? Yay. Good. You guys ready to do another one? Or are you still making your axes? Oh my, you're so slow. Just make them like I do, man. Just boom, 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 and it's done. Okay, here's the next point I want you to plot. Please plot the point 2 comma 5 pi over 6. Good luck. That's your r comma theta. And you know, someone's going to have to tell you now whether they're plotting r comma theta or x comma y. You need to know. So yes, r comma theta, good luck. Okay guys, here we go. I need my length to be 2, so it looks to be about a ½ inch beyond the end of tip of my pen, and I have to rotate 5 pi over 6, which is 150 degrees. So I rotate down to here, and it's a little bit beyond my tip, so about right there. I didn't do very good scaling, but anyway, there's B. So maybe if I made it adjusted to my scale, because if here to here is 2, then it's got to be like that. So I don't know, stupid Mr. Shannon. Maybe I shouldn't make fun of you for spending a lot of time making your graphs. But anyway, how many people got their point about right there? Okay, yay. Alrighty, well, here comes another one. Point C is going to be -3, comma 2 pi over 3. -3, comma 2 pi over 3. Well, I know what a length of 3 is, and I know where 2 pi over 3 is. It's going to be right there, correct? But what does a negative radius mean? What does an r being negative? What do I do about that? Yes, Daniel?
Your starting point's on the other side.
Beautiful. Your starting point's on the other side. That is, you should find where 3 comma 2 pi over 3 is, where 3 comma 2 pi over 3 is going to be about right there, correct? But I can't have a radius of +3. I've got to be on the opposite ray, or the opposite vector. I need to go down here. This is where C is. That's -3 comma 2 pi over 3. What if I wanted to express this with a positive radius, +3? Then what would I have to do to the 2 pi over 3? Just numerically. Instead of -3 comma 2 pi over 3 to get me there, because you know, essentially I go to 2 pi over 3 and then go across the origin, rotate 180 degrees. Well, I could rename this +3 comma some angle. What angle would I have to be?
5 pi over 3.
Yeah. You guys okay? 5 pi over 3. Because what am I adding to it? Pi, right? So I want you to see that generally, if you have r comma theta, that's going to get you the very same result as -r comma theta plus or minus pi, right? You're just rotating 180 degrees to get the negative, so that's going to be the same as that. So yeah, this would be 5 pi over 3. Good. Or -pi over 3 if you wanted to go negative. So I'd like everyone to please graph this last one, -2 comma 11 pi over 6. -2 comma 11 pi over 6. Good luck. Okay, someone explain to me in words, where does this point D end up?
Point B.
Yeah, you guys okay? Point B. This point here is also point D, negative 2 comma 11 pi over 6. Yeah, they share the same point. They are the same point. All right, hey, that's polar coordinates. Let's go ahead and start converting polar coordinates into XY coordinates. Okay, we're going to convert r comma theta into x comma y. So maybe we're with the x and y components that we're more comfortable with. And there's an incredibly easy conversion. And this, hopefully, if you were to remember one thing from Mrs. Lofgren's polar coordinates section, it would be this conversion. The fact that this point here is x comma y, that means this length from there to there is x, and this length from there to there is y, correct? And so, since this is r and this is theta, do you see that the cosine of theta is going to be x over r, or x equals r cosine theta? And similarly, the sine of theta, the sine of theta is equal to y over r, or r sine theta equals y. So I get y equals r sine theta. How many people remember that from last year? Okay, several of you. Good, good. I mean, like I said, if there was one thing I would want you to remember from polar coordinates, it would be that, the relationship between the x and y components and the r and theta. Okay, so here we go. Here's number one. R comma theta is equal to radical 2 comma 3 pi over 4. Okay? How am I going to get my x and y? Hey, just mindlessly plug in. My x is going to be r cosine theta, which means radical 2 times the cosine of 3 pi over 4. And the cosine 3 pi over 4 is negative radical 2 over 2. So this ends up being radical 2 times negative radical 2 over 2, which gets me negative 1. And my y is r sine theta, which is radical 2 times the sine of 3 pi over 4. And the sine of 3 pi over 4 is positive rad 2 over 2. So I get 1. So I get rad 2 comma 3 pi over 4 is the same as negative 1 comma 1. And you can always check your answer. I mean, you know that you've got to be in the second quadrant if you're at 3 pi over 4, and negative 1 comma 1 is in the second quadrant. You go, okay, well, I guess it's okay. You ready to do some on your own? Good. Complete lack of response I always interpret as a huge yes. So here we go. Our r comma theta is equal to negative radical 3 comma pi over 6. And so my x comma y. Please get me x comma y now. Good luck. I'll give you a hint. R cosine theta, r sine theta. Wait. What is cosine of rad 3 over 2? I mean, cosine of pi over 6, rad 3 over 2?
Mm-hmm.
Thank you. Yeah, I should always call on you when you yawn, because you get right answers every time. It's awesome. So this is going to be what, negative 3 halves? And then that's 1/2, so it'll be negative rad 3 over 2. How many people got that answer? Okay, yay. And that's in the third quadrant. And I guess that makes sense because, you know, if this is pi over 6 and this has a length of 3, that would put me there. But because it's, radical 3. But because it's negative rad 3, it's going to put me on the opposite ray. So I'm going to be right there in the third quadrant. Yeah. Okay, hey, let's do another couple. I think you guys are getting it. Or no, let's just do one. Ooh, I got a hard one for you. How fun. Here's the last one you're going to do. 13 comma, and then the angle is the inverse tangent of 5/12. Good luck with that. And you don't have to be using your calculator on this. Where is that? So how do I get what the cosine of the inverse tangent of 5/12 is? What should I do? Yes, John Vincent? No, it's not a graph.
I don't know. Triangle.
Thank you. I knew you were searching for the term. Triangle. Draw a triangle, correct? Where this is my angle, the inverse tangent of 5/12, which means that guy's got to be 5 and that guy's got to be 12, right?
Yes.
And this guy ends up being 13. Okay, so anyway, the inverse tangent of 5/12 is that angle. The cosine of that angle is 12/13, correct? So I could say this is 13 times 12/13, comma, and then I've got 13 times the sine of that angle, the inverse tangent of 5/12. The sine of it is 5/13. So I end up with 12 comma 5. How many people got 12 comma 5? Okay, well that's the way you do a problem like this. Make a triangle where you'll never know what the number of degrees of that angle is, but you don't care. It doesn't matter what the number of degrees of that angle is. All I care about is what the cosine and sine of that angle is. And I can get that by looking at the triangle. There's one thing that's kind of weird though, and I don't know if your teacher last year taught you this, but there's two types of inverse trig functions. There's the principal value and then just normal, you know? And you'll notice, how do I designate the principal value of an inverse? Yeah, Dan, no, Chris, I haven't called my Chris today.
The capital letter.
Yeah, beautiful. So you remember that with a capital letter, but you notice I studiously avoided a capital letter here. So there's actually another answer to this problem besides 12 comma 5. Did anyone get that?
Would it be like negative 12, negative 5?
Yeah, good for you. Negative 12, negative 5. Absolutely. So because since I didn't give you, the principal tangent, I don't have to just have an angle. This angle is the inverse tangent of 5/12, which means this guy is a 5, that guy is a 12, and then that guy is a 13. Then you get blah blah blah. I mean, you could also go this direction. I could be at this angle here, where this is the inverse tangent of negative 5 over negative 12. Okay, let me just write that really big. This is the inverse tangent of negative 5 over negative 12. And so I end up in the third quadrant. Okay, and so you could have gotten that answer as well. Or negative 12 comma negative 5. So I think you're going to get some problems tonight where they kind of expect you to be aware of that. So when someone gives you inverse sine, inverse tangent, you know, just be aware you'll either be in the first quadrant or the third quadrant or the second and fourth quadrants, you know, because you can make them both the opposite sign. Okay, hey, let's keep going. We're just humming along here. Here's a second. Let's see what time it is. Oh, I am kind of going slow, aren't I? What's my problem? Why do I go so slow? Why am I so slow? Okay, here we go. Let's convert x comma y into polar. Let's say we want to go in the other direction, okay? Then, again, making the classic drawing where here's x, here's y, here's theta, and here's r. Now, we're starting with x comma y, and we want to get r and theta. And so I hope you see that x squared plus y squared equals r squared, which means r is going to equal the square root of x squared plus y squared. That's one conversion. If I give you x comma y, you can get r by using that formula. And I hope you see here that you end up theta equaling the inverse tangent of y over x. Alrighty? Now it gets a little tricky because sometimes you're in one quadrant and sometimes you're in the other quadrant, and you're going to have to use your cleverness to figure out which it is. You're going to have to use your common sense. Because essentially theta could be one of either of these, or theta equals the inverse tangent of y over x plus pi, you know, or minus pi. You know, well, really, yeah, plus pi. Just say plus pi, and you know, which quadrant are you in? Use your common sense. Here, let me give you a problem, okay? How about part A? How about 2 comma 2? That's my xy, okay? I want to get the r and the theta. Well, the r is usually pretty easy. The r, I'm just going to take the square root of the sum of the squares, so it's going to be radical 8. You guys okay with that? So the r is going to be radical 8. Or 2 radical 2. What's my theta going to be?
What?
What's my theta? Say, yeah, pi over 4. How'd you get that?
Like inverse tangent.
Okay, inverse tangent. Or did anyone just plot 2 comma 2 and realize it makes a 45-degree angle with the x-axis? That's fine too. But either way, you get 45 degrees or pi over 4. Okay? Because the inverse tangent of 2 over 2 is equal to pi over 4. Alrighty? There's another answer, of course, and your book asks for it as well. And when they say get me another answer, they mean get me a negative radius. So if my radius were negative rad 8, what would my angle be now instead of pi over 4?
5 pi.
Yeah, just add pi. They're essentially saying, hey, you know, instead of being right there with rad 8 comma pi over 4, go ahead and go to 5 pi over 4, add pi to it, be here, but then have the negative radius, and that'll get you right there as well. All right, you guys, I'm going to give you an easy one, and then I'm going to give you a hard one. Go ahead and get me r comma theta if x comma y is 0 comma 3. Good luck. And feel free, please, to just use your intelligence. I mean, you know where 0 comma 3 is. You know, if this is the x, y, there's 0 comma 3. Just go, hey, you know, what's the radius?
3.
3. What's the angle? Yeah, so feel free to use your cleverness. Don't feel like you have to, you're not honor bound to plug into those formulas. Okay, here, let's do one more. How about my x comma y equals negative, oops, I'm sorry, equals radical 3 comma negative 1. Good luck with that. Plug into the formulas. Get your R, get your theta. Alrighty, so what'd you get for the R? 2, great. And what'd you get for the angle? Okay, how many people got negative pi over 6? That's fine. How many people got 11 pi over 6? That's fine too. Can I make one recommendation? I can't think in radians. I only think in degrees. So it is okay with me if your calculator is in degrees mode when you're doing all this stuff. And then you just convert to radians when you write down your answer. Like me personally, I would have it in degree. Because if I'm in radians mode, I get some weird decimal that I don't recognize at all. But if I'm in degrees mode, I do inverse tangent of that, and I end up with negative pi over 6, you know? So, I mean, with negative 30 degrees. So, and then I would convert the negative 30 degrees to negative pi over 6. So yeah, you can call that negative pi over 6, or you can go 2 comma 11 pi over 6. Or if you prefer, you could go negative 2 comma, add pi to that, so now you're going to have 5 pi over 6. You know, those are all good. Alrighty, hey, that's converting x comma y to r comma theta. You're going to get some problems tonight where you get to do it. And check your answers, always check your answers. Make sure you get them right. And I want to just reiterate, whenever you're interacting with the calculator to help you with this stuff, then I would be in degrees mode. Okay, here we go. What is it? Polar graphs. I need to show you just a couple of simple polar graphs. So, 2 simple polar graphs. Alrighty. The first one is r equals 3. There's my graph, r equals 3. You tell me, what is the graph r equal 3 going to look like? Yeah, it's a set of points that are all 3 away from the origin. Do I care what the angle is? No. So it could, you know, this is 3, 3, negative 3, negative 3. It'll be that point and that point and that point and that point, or that point or that point and that point, and the whole set of points that are 3 away from the origin. Well, that makes a circle. Okay, oops, I kind of messed that up. So I just want you to be aware, if you've got the polar graph r equals a number, that's always a circle, because that's a set of points 3 away from the origin. The second common graph is theta equals pi over 3. I don't care what the r is, as long as the angle is pi over 3. Well, you tell me. What's that graph going to look like? You guys okay that it's array? Pi over 3, you know, I could be, where's pi over 3? Like 60 degrees? So I could be there, or there, or there, or there, or there, or have a radius of 0. So is everybody okay that this is the graph of pi over 3?
Why aren't there any like negative radii?
Wait, what? Say that again, Zach.
Why aren't there any negative radii?
I don't know. Why not? Because I didn't write them? Are you guys okay with what Zach is saying? So this isn't array. What should it be? Yeah, thank you very much. It should be a line, because I've got to include not just my positive, oops. I was thinking of sequences and series there, geometric, greater than 1. Not only is my r greater than 0, but my r gets to be less than 0 as well. Okay, so yeah, it's going to be the straight line. It's not a ray. The graph of theta equals pi over 3 is a line, because you're going to have positive radii and negative radii. Pi over 3, negative 2 gets me there. Okay, great. Hey, let's keep going. So now I want to go from a polar equation to a Cartesian equation. And I hope you know Cartesian equation means it's named after, well, you tell me, what's Cartesian coordinates? Who's that named after? You don't know? What man? Cartesian coordinates or Cartesian equations? The Cartesian axis system. You don't know who that's named after? Jimmy Carter? Yeah. No, there's this famous guy named Rene Descartes, right? And he was sick one time, he's lying in his bed, and he's supposedly watching a fly or something walk along the wall, walk along the ceiling, because he's on his back, he's sick. And he's watching him walk along the ceiling, and he's able to, because the ceiling is tiled, he was able to track the progress of this bug by keeping track of the x and y coordinates, and thus was born the Cartesian coordinate system. Okay, well anyway, when you get polar equation to Cartesian, you're going to use these conversions. R equals the square root of x squared plus y squared. Because someone's giving me a polar equation and I want to turn them into Cartesian. So if you've got an R, you're going to do that. If someone gives you a cosine theta, you're going to say, well, I know cosine theta is equal to x over r, which means that's equal to x over the square root of x squared plus y squared. So you'll make that conversion, and you'll make this conversion as well, y over r, which means y over the square root of x squared plus y squared. And then finally, if it's just a theta standing alone, which happens once in a great while, that's going to be the inverse tangent of y over x. So those are the conversions. So hey, let's do part A. R cosine theta equals 0. R cosine theta equals 0? Why would I do that? Okay, well, whatever. That's fine. Okay, please put that in. What is that an equation of in Cartesian land?
Is it like a straight up and down line?
Yes, it is. Just making it equal to 0 is kind of dumb, but I guess the Mr. Shane of the past must have known what he was doing. I would have done like R cosine theta equals 5 or something. The Mr. Shane of the present. You guys okay? What is R cosine theta another name for?
X.
X. X is R cosine theta. So this is the same as x over 0. Okay? So that's the graph you would make. Here, let me give you another one. How about R equals 6 times the secant of theta? Please do that problem now. Turn this into a Cartesian equation. Did anybody do this? R is the square root of x squared plus y squared. Secant, since secant is the reciprocal of the cosine, instead of doing x over that radical, you do that radical over x. Anyone do that?
No.
Okay, well then you cancel out, notice the radicals cancel, you multiply both sides by x and you get x equals 6. How many people got x equals 6?
What if you just flip the secant theta to the other side, making it r cosine theta is equal to 6?
Wait, what? You mean I could just call this r cosine theta equals 6? How many people did it that way? Oh, you guys are so much smarter than I am. Okay, great. And how about part C? What if I had r equal 4? What's that going to end up being? Okay, I'm going to have to hurry it up because we only have 2 minutes left. So I hope you put for r, x radical x squared plus y squared equals 4. We get x squared plus y squared equals 16. What's that the graph of? Yeah, circle. So that was easy. Okay, here we go. 2 minutes left. I'm going to go fast. Let's say you want to go Cartesian equations, and you want to convert to x comma y. You want to convert to what do you call? I'm sorry. You want to convert to polar. What am I doing? Cartesian is x comma y. You want to convert to polar. Okay. I don't have time to do any problems with you, stupid me. But remember, just make these incredibly easy substitution. Oops. Okay. I got to tell you one more thing. So don't turn off that video. Okay. So just make those substitutions. And then the last thing, when you graph polar curves, like let's say I had a polar curve r equals 1 plus sine theta. You know what I would do if I were you? I would either make a table of values, just have a table of values, here's my theta and here's my r, and then just graph them like we did in the early part of the period, or use your graphing calculator if you want to take a look at it, and just make sure you're in polar mode. And then you've got to decide between degrees or radians and do all that other stuff. But right now, for tonight's homework, just making a table of values should be good enough. Good luck, you guys.